Okay, here is the last type of game that we would study in the game theory part of the course. Games with incomplete information. What does that mean? So all the games that we have studied up to this point, we assume that all the players know what possible strategies the other players have and what payoff they will receive when certain combination of strategies occurred. However, unfortunately, life is not that easy, at least not always, right? So in many situations, information is not complete to all the players, which make things a bit more complicated and require different setup. So what does incomplete information mean? It means some players in the game may have more information. Usually it's called private information among the literature than the others. So of course that will alter the strategy that the player with more information will play, but it also will affect the line of reasoning of the players who have less information. So they will try to collect all the information that they could and then make inference about what they do not know exactly. One example you could think about, for example, when you buy a second-hand car, a used one, there's also a famous example when studying such game. Now, usually the chance is high that the buyer of this used car will have much less information than the seller of the car about what? About the condition, the quality of the car, right? So how do we deal with such situation? We're gonna look at it today. Let's go. Because the situation, the problem at hand with incomplete information is already quite complicated. So we will start with the simplest possible version of this game, which is the simultaneous move, like several before. One player, here called player one, has private information, but player two does not. And the basic private information form to start with is about the type. So player one can be of a number of possible types, denoted T. Player two certain about his own type. It's very straightforward, only a single type. Both player two and player one knows that. However, player two is uncertain about the type of player one. He doesn't know for sure. In the car example again, like player one is the sailor, know for sure how honest he is or how the condition of the car is, if it's a good one or a bad one. No. But player two does not know exactly about it. And therefore, he must rely on certain beliefs about T and infer his strategy upon this belief. That's the setup. Let's first go through the formality of the game, the model, and then later we see how it look like on the board. So go through the slides first. So in order to model the uncertainty in the type of player one, we introduce something called a chance node. What is that? It just simply means another decision node added to the game, but in the very beginning. Sometimes in the literature, it's also called the move of nature. That is, we imagine nature is the one who picked the type of player one from a set of all possible types. Let's say player one can be one of K types from T1 to Tk, and the nature will randomly draw one of these elements out, and his type is determined since then. So because it's determined in the very beginning, before player one moved, he sees which type he is, presumably. However, player two does not know this. And what he all knows is the probabilities, here denoted PR with TK in the bracket, meaning the probability of the realization of type TK, a certain type. So at least he knows that there's such a set, which elements are in that set, and which probabilities attach to each element. That was player two. No. Again, since the first player observed T, he knows what his type is, so he could decide his strategy upon this information. So condition on T, what does condition mean? Just mean, okay, if I'm first typed, then I go for this strategy. If I'm second typed, I go for this other strategy. That's conditioning. However, because player two does not know the type exactly, so his strategies cannot follow this line of argumentation. It's just simply a strategy among his possible strategy. Okay? One thing to keep in mind, that there are two different ways that the type of player one may affect the payoff of player two. Not just in general affecting, but in two different channels. We should see that directly. Back to the example of the used car. If a car is good and the trade happen, your payoff, of course, will be different from when the car is bad. That's one thing. Another thing, it may also affect the payoff through the strategies that players one adopt contingent on his type. So if the car is good, maybe the seller will go tough on bargaining. He would not accept your proposal for a large discount also, and also on kind of relating cost. He would go tough because his car is good. And however, if the car is bad and he knew that, then he would like to sell it more, right? Eager to sell it to you. So probably he would offer you some extra services and all kind of related stuff, give you a bit discount. And that's also will affect your ultimate payoff or the price you buy the car and what value you get at the end, right? This is again the normal form of this game now with the payoff of the first player replaced by his type T. Normally, the payoff will be a function of T. In many complex games, it could be a more complicated function of T, not just T itself, but here we will focus on the simplest version of the game. Also, all other payoffs stay the same for both types. And we assume also that T can be either 6 or 0, which equal probability. So P of T equals 6 equal P of T equals 0 equals 1/2. No? So that's the basic assumption of this simple game. I will show you on the board how the extensive form look like with the move of nature. No? Okay. Now I show you how the Bayesian game looks like with the normal form and then how the decision tree, the extensive form, will look like with this game now. So the game started with all the payoffs, no, except for one cell only where the combination is player 1 plays up and players 2 plays down. Sorry, plays left. So that's the only thing where T, the type of player 1, would have an impact. No? So T could be either equal 6 or 0 with the same probability, 1/2 here. No? So we could just split down this very compact form of the Bayesian game into two different normal forms of two different games, one for each case. No? So if T equals 6, with this probability, the game becomes this matrix. Otherwise, it would become the below, the bottom matrix. No? And all these three matrices almost the same except for the place of T here, which I replace, okay, with either T is 0 or T is 6. Now, so that's how we think about it. Now, talking about extensive form, remember I told you that the game's now extended one node to the left, which is the move of nature. So in the very beginning, this is the chance node, or I would say nature. So nature will pick the type of player 1. So nature plays first. So that would be T equal to 6, one case with probability 1/2. Or T equals 0 with probability 1/2. So, okay. Now comes the decision node of player 1. So player 1 could, contingent on his type, play up or down. Now, up or down. Okay. Then comes the decision node of player 2. However, remember that this game is simultaneous. So player 1 can play contingently or conditionally on the play of nature, but player 2 cannot because he doesn't observe that. Okay? So he could have two possibilities, left or right. So left or right. And then left or right. Everywhere. Okay, and then now we will fill in the payoff in each case. So the first branch of the main branch of the decision tree here is for the case where t equals 6. So we focus on this first matrix. Up, left, 6, 2. Now, upright, 0, 0. Then down, left, 2, 0. Down, right, 2, 4, right? And now it comes to the next main branch, the other one where t equals 0. So up left will be 0, 2. This is a little bit far. Okay, 0, 2. Sorry, 0 here, and then 2 here, a bit ugly. Okay, up right, 0, 0. Down left, 2, 0. And then down right, the remaining is 2, 4. So actually, the extensive form of this Bayesian game is just extended to the left with one decision node from the nature, and each of the main branch will assemble one extensive form for one game, corresponding to these two normal forms, right? So that's the difference now.